All right, on to exercise 2. This exercise dealing with significant figures. Give the number of significant figures for each of the following experimental results. Now, if you've already looked down at the bottom, I have the answers here. But not only do you need to just show me the answers, you need to be able to tell me how you got those answers. So, don't cheat. You're just cheating yourself. Give the appropriate number of significant figures for each of the following experimental results. So this is an experimental result. It is a measurement, which tells us it's not an exact number or a counting number, so we're going to have to count the number of significant figures. So a student's extraction procedure on a sample of T yields 0.0105 grams of caffeine. Now, I'm going to start with these two non-zero digits. Bam, 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 bam. Those are both significant figures. What about these first two zeros? Are they terminating? No, they're actually in front of the number, right? They're to the left, so they're definitely not terminating, so the whole first criteria is out. Are the zeros in question sandwiched by significant figures? No, there's nothing significant over here. There's something significant right here, but not to the left. So these are not significant. No, no. So we're going to check to see if this 0 is significant. And I see that it, in fact, is sandwiched between the 1 and the 5, which is the second criteria for a 0 being significant. So this is significant. So 3 significant figures. B, a chemist records a mass of 0.050080 grams in an analysis. So here are my my non-zero digits. Those are ones that are easy, so I got 2 so far. I see my 2 zeros in front here. They're not terminating, so those are not. Right, they're not terminating, so they're not criteria 1. They're definitely not sandwiched between anything, so they don't satisfy criteria 2. I see these 2 zeros are sandwiched between the 5 and the 8, so they are significant. I'm up to 4. And this last 0, it is terminating, and it is to the right of the decimal. See how it's terminating? It's at the very end of the value, and it's to the right of the decimal. So, boop, boop, that is 5. And C, in an experiment, a span of time is determined to be 8.050 times 10 to the negative 3 seconds. Pretty short amount of time. Anywho, or as Ludwig von Drake says, anyway, 8.050 times 10 to the negative 3 seconds. So we have 1, 2 non-zero digits, so those are definitely significant. Look at my first 0, which is sandwiched, so that is significant. I'm up to 3. And then the second 0 is terminating and to the right of the decimal, so I'm up to 4. Correct answer is 4. Now, there are a couple other things I want to point out. All this gobbledygook back here does not affect the number of significant figures in a value that is written in scientific notation, which this is. So when I'm looking at the times 10, don't look at the 10, right? Don't look at the 1 from the 10 and try to add a significant figure. Also, don't look at the exponent and add that number of significant digits to your answer. They don't affect the number of significant figures. The only things that are going to affect the number of significant figures are the actual digits related in that coefficient. Now, there is one thing that you could have known immediately by looking at C, is that this number is in fact in scientific notation, and any value that is in appropriate, right, has to be correctly done. But if it's in proper scientific notation, every single digit that's there is significant, because it turns out that when you change something from standard notation into scientific notation, you only include significant figures. So, because it's in scientific notation, by default, all of them are significant figures.